Hello everyone, what I would like to do is go over an example similar to 3.1.27 in the homework. So you take out a 30-year loan with interest 1% per month and monthly payments starting at $1,000 at the end of each month and increasing by 0.5% each month. Find the outstanding balance at the end of 9 years. So in some sense, this is really just plug and chug. We're just going to use the retrospective method. Okay, so to do that, we need all the payments after the 9th year. And first of all, I want to make clear that what does a 9th year really mean? Well, that means T is 108 because that's 108 months. 9 times 12 is 108. So we need to use the retrospective method when T equals 108. Okay, so let's first get the formula for the payments. So K1 is just, the first payment starts off at 1,000. Then it increases by 0.5%. So it's times 1.05. If it was 5%, it would be 1.05, but it's 0.5%, which is 0.05%. So it's 1.005. Okay, then that increases by 5%. So the pattern really should be pretty clear. K3 is really 1,000, 1.005 raised to the power 3 minus 1. This is really 2 minus 1, or the power 2 minus 1. And this is really times 1.005 to the power 1 minus 1. So in general, KT, the payment at the end of the Tth month, is 1.005 to T minus 1 times 1,000. Okay, so in our retrospective method, we have, here's our T. So T is 108. This is a loan that lasts 30 years. So that's 360. 30 times 12 is 360 months. Okay, so the formula is you start off with KT plus 1. So this is T plus 1 times new KT plus 2, new squared, all the way to K n, and then it's new to the n minus T. Okay. N, again, is 360, 30 times 12, and T is 108. Right. And we said that the monthly interest rate is 1%, so that gives us a present value factor of 1 over 1.01. Okay, so make sure we're all on the same page here. Well, K109 is just 1,000, 1.005 to the 108. Remember, whatever we stick here, whatever is here, the payment corresponds to 1,000, 1.005 to whatever is here minus 1. We got a 109, so it's 109 minus 1. We got a 110 here, it's 110 minus 1, et cetera, et cetera. So it's K109, which is exactly what I'm putting in the bracket here. K109 times present value factor, K110 times present value factor squared. And this is getting a bit crowded, so let me start erasing some stuff here. Erase this here. So I'll just erase all this because I went over it already. And yeah, it takes a minute to erase. So, right, so this is K109 times new. This is K110 times nu squared, all the way to K360 times, well, 360 minus 108 is 252, so it's nu to 252. Okay, so what I want to do is factor out, so I start off this with a 1. So everything starts off with a 1 here. So I'm going to factor 1,000, 1.005 to the 108 times 1 over 1.01. Okay, so let me get rid of some of this here. Get rid of all this. Give me a second. Sorry about that. Right, so what I want to do is, yeah, factor this term out here from everything. Okay, I'm going to factor this term out from everything. And when I do that, if you do this carefully, you'll get a nice, easy to sum finite geometric series. Okay. So I factor this all out, and I'll just put the 1.01 on the bottom instead of making it times 1 over 1.01. So it's 1,000, 1.005 to the 108 divided by 1.01. Okay. If I do that, well, that's just 1 here. Okay. For the first term, because that's exactly what I have here. I'm factoring this out. Okay. Now, if you factor it out from this one here, I'm factoring out a 1.01, so this becomes a 1. I'm factoring out the 1,000, 1.005 to the 108, so this becomes a 1 here. So you get exactly this here. Or if you want to think, you take this, distribute it here. Well, we distribute it here. We already said we get this term here. If I distribute this here, I get 1,000, 1.005 to the 109 over 1.01 squared. Same thing, 1 over 1.01 squared. And that's exactly what I have here. Just play this game, factor this out from this term here. What are you going to get? You're going to get 1.005 to 251 over 1.005 over 1.01 to the 251. Because 108 plus 251 is right, sorry, 108 plus 251 is 359. Okay? So you get right, you could get the correct exponent for the 1.005. And 251 plus 1 is 252. So you get the correct exponent for the 1 over 1.01 here. So this one is correct. When you FOIL, this one's correct. All right. Right. Right, so FOIL this one here, you get exactly what's here. Again, 108 plus 251 is 359, which I have here. 108, a 1 plus 251 is 252, which is exactly what I have here. Okay, so this is, yeah, you can sum this up very easily. So let's get rid of this here. All right, so this is my R. So it's 1 plus r squared plus r to the 251. So the formula is going to be, my exponent here is 251, so it's 1 minus the exponent plus 1 over 1 minus my exponent. My exponent is r, the number here is 251, so it's 1 minus r to the 252 over 1 minus r. All right, so yeah, let me show you how I would do this in the calculator. Okay, so I probably would maybe just get this number here and store it. You don't really have to do that, but maybe it makes life a little easier. 1.005 over 1.01 store 1. All right, so I would raise this to the 252. Put a minus in front of it, plus 1. That gives me the numerator. And I want this whole thing divided by 1 minus what I stored. Just recall 1. And I get 144,162,0703. All right, so I would do this step by step. Doesn't matter how we do this. Let's times by 1 point, whoops, a little careful. So 1.005 to the 108 divided by 1.01 times 1,000. And you get your answer. The 4 is hiding there. Or sorry, the 2 is hiding. But you get your answer, 244,604.42. So using this calculator for calculations really isn't that bad if you are careful with parentheses and, you know, yeah, if you do things step by step and you make judicial use of the storage keys, that's why they're there. Yeah, I mean, I maybe would actually use TI-XS Multiview for doing these calculations, as I mentioned, I think, before. You're allowed to have both calculators for exam FM, but yeah, even just using the BA2 Plus really isn't that bad. So yeah, hopefully this helped. And yeah, as this problem indicates with the S here, that means this was a previous exam FM problem. So exam FM wants you to know how to do these kind of basic calculations and algebraic factoring to use get a finite geometric series. And again, the basic idea is just the retrospective method, just plug and chug. All right, hopefully that helped. And so long, take care, until next time.